In this lecture, I'll explain you combination of capacitors. It is a very important topic and you will get the numericals based on this topic in the exam. Okay. So there are two combinations, series and series combination, and second one is parallel combination. Okay. So I will discuss first the series combination. I'm writing the series. So what does the series combination of capacitor means? Basically what will happen, the capacitors are connected in series. Okay. So let us say this is the first capacitor, this is the second capacitor, this is the third capacitor, and they are connected in series. So I'm just connecting these capacitors into series. And okay, so if they are connected in series, that means there is a voltage source. Let us say the voltage source is, this is the voltage source, okay, and this, let us say this is the voltage source V, and this is plus and this is minus. The long line is the plus, smallest line is the minus. Okay, let us say this is C1, this is C2, and this is C3. Now if we know that, suppose this is a combination, this is a capacitor, this is a combination, and it is connected to a battery like this, right? That means what will happen, this is a capacitor and this is the battery. That means capacitor will have same potential as battery if it is connected directly. Okay, if it is connected like this. Now I can write such a combination in which charge stored on each capacitor is same, whereas potential difference across all capacitors is different, is known as series combination. Okay, I'm just converting it into language. Okay, so I can write such a combination in which charge stored on each capacitor is same, whereas potential difference across all capacitor is different, is known as series combination, right? Because if they will be connected like this, then they will have the same potential if they will be connected like this, but they are connected in series. Okay, so what will happen, the potential difference, the total potential difference will be addition of V1 plus V2 plus V3. Okay, so because this is the positive charge, so it will be here positive and this will be here negative. Due to this negative, the positive will come out, and on the other plate there will be negative. Due to this negative, the positive will attract towards it, and then it will be the negative charge here. Okay, and let us say this is Q1, Q2 and Q3. Now this is the series combination. Okay, now what I can write is total potential difference across the combination. If I need to write the total potential difference across the combination, can you tell me what will be the total potential difference? V is the total potential difference, will be equal to V1 plus V2 plus V3. Okay, if it is V1 plus V2 plus V3, and we know the relationship between Q, C and V. What is that relation? we all know, we know Q equals to CV. That means I can write C equals to Q over V. So what will happen? Sorry. Because we need the value of V. So V will be equal to Q over C. So can I write V equals to Q1 by C1 plus Q2 by C2 plus Q3 by C3. So this is my total V, right? But Q1 equals to Q2 equals to Q3 equals to Q, because the charges stored in all the capacitance will be the same. So what will happen? V equals to, I can take Q common over 1 by C1 plus 1 by C2 plus 1 by C3. And what is V? V is Q by C equals to Q 1 by C1 plus 1 by C2 plus 1 by C3. And Q is cancelled out. So I can write the final equation will be 1 by C equivalent equals to 1 by C1 plus 1 by C2 plus 1 by C3. Okay. So I can say that equivalent capacitance of series combination decreases. Okay, because it's a series combination, equivalent combination is decreasing. So please remember, if it is a series combination and you need to find the equivalent capacitance, you will just use directly this formula and your equivalent capacitance is solved. Okay, now next is parallel combination. If I need to do the parallel combination, so how I will do the parallel combination? It's as simple. So this is my one capacitance, this is my another capacitance, and this is my third capacitance. So there are three capacitance. Let us connect like this. Okay, and they are connected with a battery here. So this is the battery. Okay, so they are connected with a battery. Let us say the charges are Q1, Q2, Q3, capacitance is C1, C2 and C3, and the potential difference is V and V. See, now these are connected to a capacitance. So in the parallel combination, so what will happen? The potential difference will be the same in parallel combination. In series combination, what happens? The potential difference is not the same, they are different. Now, so I can write the definition. Such a combination in which charge is stored on each capacitor is different, whereas potential difference across all capacitance is same. Okay, so total charge is stored on the combination. What is the total charge is stored on the combination? It is Q equals to Q1 plus Q2 plus Q3. That means what is Q? Equals to CV equals to C1 plus V1 plus C2 plus V2 plus C3 V3, and then CV equals to V, because V1 equals to V2 equals to V3 equals to V, then it is C1 plus C2 plus C3, V and V is cancelled out, then C equivalent equals to C1 plus C2 plus C3. So if we need to find the C equivalent when the capacitance are in parallel, then it is the C equivalent. So net capacitance of circuit increases when they are connected in series. Okay. The next and the last topic of capacitor is energy is stored in a capacitor. So if we need to find out the energy stored in a capacitor, how do we find out? So we know that dW equals to delta V dQ. Okay, and delta V equals to Q over C. You all know these formulas for a capacitor. Okay, so this is basically the work done. The work done equals to V into dQ. Okay, so can I write dW? What is delta V? Q over C into dQ. Let us integrate it because we need to find the total work done. When we need to find the total work done, this is the smallest d. So we need to integrate it. 0 to Q. So it will be Q over C into dQ. So when we integrate it, it will be 1 by C is the constant, and integration of Q will be equal to Q2 square by 2, and it is 0 to Q, the limits. So W equals to 1 by C, Q square by 2 minus 0. And we know C equals to Q by V. So W equals to U equals to half Q V square. C equals to QV. So maybe I can write QV square. Okay. So Q by C is, yeah, so just basically what we can write, or I can write it CV equals to Q, or maybe Q by C equals to V. So from this we can write this equation. Okay, so this is the formula you need to remember when you need to find out the work done. Okay, so these are the formulas you need to remember: capacitance in series, capacitance in parallel, and the work done.